surrounded by variety of flowering plants. If you go on enlisting them, the list won't end up at all. In our gardens and parks, we have thousands of flowering plants. If you go to orchards, there we see flowering plants which give us fruits. Now all the flowering plants, depending on their characteristics, have been divided into two groups. One, dicots, the other one, monocots. Here cot means cotyledon. If you add mono to that, monocotyledon. In short, we say monocot. Dicotyledons, two cotyledons. Dicot in short. As the name itself suggests, plants that have two cotyledons in their seed come under dicots. They are named as dicots. Dicotyledons. Plants with only one cotyledon in their seed is called as monocotyledon, or in short, monocot. Let's discuss now. I'll take the example of a gourd, garden gourd plant. It gives gourds. It's a vegetable plant, a tiny sapling. The sapling has two cotyledons here. See, these two cotyledons were there in the seed of the plant. When the seed was sown, it absorbed water from all around. It got swollen up, then it germinated. As it germinated, the two cotyledons separate out. And they too grow, just like leaves they grow. And these cotyledons will have enough food for the growing plant. Because the young plant, its roots may not be able to absorb nutrients from the soil to the extent required. So what do these cotyledons do? These cotyledons were the two halves of the seed, inner halves of the seed, full of nutrients and food as well. Now they have grown into almost leaf-like structures. You can see them, one here, one here. And day by day, they become thin and ultimately they wither out once all the food is made use of. They are green too. In the presence of sunlight, they can even prepare food. So it helps the tiny plant to grow up. Once the plant has grown to a particular level, the true leaves start appearing. See the true leaf? It is, the sides are serrate, it's star-like, it's a long stalk, then the leaf has veins on it. This is the actual leaf of that gourd plant. This is not the leaf, looks like leaf, but this is the cotyledon in the seed. How many cotyledons were there in the seed? Two cotyledons. That's why you call this gourd plant as a dicot. It has two cotyledons. The cotyledons, they protect the plant when it's too young. Then later they open up, the plant comes out. As the plant starts growing, the cotyledons give away all the food they have stored in them. The plant will grow up. Then they have turned green here. They have tried to prepare as much food as possible in sunlight. That too is supplied to the plant. Some of the cotyledons, they sacrifice everything to see that the gourd plant stands. The gourd plant succeeds in growing up into an adult plant and produce flowers and seeds later. So the cotyledons play an important role. Now here in a dicot plant, you look at the root system. There is a thick root here at the center. And other roots have evolved from that main root. The main root, the continuation of the stem down, that is the taproot. Or you can call it as the mother root. It's thick, it's strong, it grows and grows into a long root, evolving a number of lateral roots on it. These are lateral roots. See, these are lateral roots. As against this, when you come to a monocot plant, here I have the monocot plant. I'll take one for study purpose here. See, in a monocot plant, all the roots are almost of the same thickness. You cannot make out any mother root there. Though there will be a mother root to begin with, the mother root withers away. And all these roots are tiny roots. They all take birth from the tip of the stem. Tip of the stem. They grow like this. You pull out any grass plant or a tough grass, you will be able to see hundreds of roots which will be holding soil. If you wash, you get all the roots. Have it as a follow-up activity. This is a monocot plant. All the roots here, they take birth from the tip of the stem and they are all of the same thickness. Their length is almost the same. They all grow in different directions. See here too. Do some field study. You will be able to find out the difference between the dicot root and the monocot root. There is no taproot here. All the roots, these roots which have the same girth thickness, they are called as fibrous roots. This system is called as fibrous root system. Whereas in the gourd plant, which we took as an example for dicots, has the taproot system. Now coming to the seeds, I told you already, this is groundnut, shenga. It looks as if it's one cotyledon. No, not. It's not. I just press it here. If I press it, there's a seed coat. Inside the seed coat, we have two cotyledons. It has come now, come out. You have seen, you have eaten, you know it. But let us just study it from a study angle. See, two cotyledons are there. They are connected by a hinge-like structure here, two cotyledons. Dicot, two cotyledons are there. So groundnut is a dicot plant. Why are these thick? These seed with its two cotyledons has stored enough food for the tiny sapling which will emerge out of the seed later on. It has enough food. Otherwise, where will the tiny plant which cannot draw food on its own grow? So the cotyledons, they support the sapling by giving away the food that it has stored in it. Same thing with the Bengal gram. There too, if you break it, you get two cotyledons. You come to paddy. I have rice here. If you take up one single grain of rice, you don't see, you can't divide it into two pieces. It's one single grain, monocot. Rice is a monocot. From this, if it's paddy, from rice you cannot grow a plant. Paddy with its seed cover, you call it as paddy. plant a few paddy grains, water it, and wait for a few days. The sapling will come out. It will carry that grain with it. The paddy grain will be there with the plant. The food is stored in rice. From here, the food will be drawn by the plant that grows out. It's the case with all the grains. All pulses have two cotyledons in them. All grains which become our prime staple food, they have one cotyledon in them. You take the example of ragi. Ragi is a special staple food item from India, ragi. They are granular, round, and each ragi seed will have one cotyledon. Take a few ragi seeds, soak them in water for an hour and put them in soil or in a small pot and see how the plants sprout. How do they come out? You see the cotyledon, single cotyledon there supplying food to the growing plant. Quite interesting when you watch them in action. These tiny plants as they grow, they turn to be very charming. Okay, this is a monocot. Now let us come to the leaves. Again, I have taken hibiscus here. Hibiscus is a dicot plant. It's a dicot. Here I have the leaf. Let's see what difference is there in the leaves of dicots and monocots. Hibiscus is a dicot plant. Look at its leaf. In the leaf, you have the stalk part here, stalk of the leaf. Then the midrib is there, midrib. Then lateral ribs are there. They are the veins, they have veins in them. Veins. And the edges are serrate. Beautifully they are cut. And here if you look at the veins, they just divide again, and it will be a reticulate structure, a net-like. It's net-like. If I try to tear a leaf, I cannot tear it straight. You see, it goes in different ways. It goes. I will not be able to tear it straight. This kind of venation, these are veins through which water is supplied to the leaf, and food that is prepared in the leaf in the presence of sunlight, that is sent to the different parts of the plant. So veins are very important. They are like blood vessels in our body. In plants you have veins. They supply water. Prepared food is taken to other parts of the plant by these veins. Now the veins are reticulate in a dicot. We will take a monocot now. This is a monocot. We can discuss with this. See, the veins are all parallel. The veins run like this. In all the monocots, the veins run parallel to one another. We will take an example here. This is a garden plant. I brought a leaf. By looking at the leaf, a botanist or somebody who has studied, he can very well say whether it is a monocot or a dicot. This is a dicot because the venation is reticulate. Here the venation is parallel. You can see there, they are colored. They are colored too. The veins run parallel to each other from this end to this end. If I try to tear, you can make out. See, it goes straight here. Straight it goes. You can very well see it in banana plant. See. This is an ornamental plant, not actual banana plant, but it is a canna species. It is a canna species. In fact, here all the veins run like this. Mid vein is there. From the mid vein, the veins run parallel to each other. to both the sides, to either sides. If I tear it here, you see it runs straight. It doesn't go zigzag. You know it in banana leaf. Even as the wind starts blowing, high speed wind blows, the banana leaf gets torn into bits. But all those which are torn, the line where it has got cut, torn, they all run parallel to each other. So the venation here in a monocot plant is parallel. See the differences, we will just find out here once again. Here I have a dicot plant. A dicot. Both are flowering plants. All the flowering plants I am revising. All the flowering plants are divided into two groups, dicots and monocots. Here you see the dicot seed. It has two cotyledons, hence it is called as dicot, dicotyledon. When you come to the monocot, it is a single cotyledon, monocot, one cotyledon, single cotyledon. So this is dicot, this is monocot. What are the other differences? You look here, a dicot plant has a long, thick mother root. You call it a taproot. These are the lateral roots which take birth from the main taproot. Coming to the monocot, number of roots are there. All the roots are of the same thickness. They all evolve from the tip of the stem here. The bottom tip of the stem. So it's like a tuft. The roots are like a tuft. Third one. Here in dicots, you have reticulate venation. Here I have given a drawing of a rose leaf. Reticulate, steady. Here parallel venation, a banana, a cut banana leaf is shown here. Venation is parallel. You have the chart here. Aspects, these are the aspects. Dicot plant, monocot plant. Roots, taproot system, fibrous root system. Leaf, reticulate venation, parallel venation. Seed, two cotyledons, one cotyledon. Examples, mango. You may feel there is only one stone inside the mango. It is monocot. No, not at all. You break it. If you break, you have two cotyledons inside. It's a dicot. Mango, rose, hibiscus, pea, tulsi, grams, all pulses. They all come under dicot plants. Monocots. Paddy, we had the example here. Wheat, grass, all our staple food items like ragi, maize, wheat, rice, all these they are all monocots. Then maize, palm, coconut tree. Coconut tree is a monocot. The leaves are all, it is a compound leaf and the venation is parallel. Even coconut, you remove the husk, you have the shell inside, break the shell, inside you have only one cotyledon. It's a monocot. All palm trees are monocots. Maize, palm, banana, plankton. So this is how the flowering plants in the world have been divided into two major groups. This you should remember very well. These help us in knowing whether a plant is a monocot or a dicot. A gardener should always know what his plants are, to what category do they fall. So do some field work. Go around, observe plants, study their venation. You will not get the seed immediately. Venation of the leaf you can study. Usually somebody who would like to do some investigation in the garden would start with the leaf, because To know the roots, you may have to lift it. You may not like to destroy the plant. Okay. Seeds, the plant may not have seeds right at the time when you want to investigate. So what is it you get? You get the leaves. You take the leaf and find out whether the venation is reticulate or parallel and decide based on that. Thank you.